here's an illustration of how, a very simplified, it's called a ray trace, of how any particular sound wave might move in a room. And it's assumed to behave a bit like a mirror, so every time sound reaches a boundary, it reflects like light would reflect if it were hitting a mirror. Now, even though sound behaves in quite an unpredictable fashion, it tends to, especially when it's being radiated from a loudspeaker, this does help us understand, and gives us some intuition for why the room makes such a difference to the sound that we're listening to. And you can see that for the picture on the left, this is just a very small number of reflections that are drawn in here, but you can see that when the listener actually hears the sound, they're not just listening to the direct sound as it comes from the loudspeakers, they're also listening to a whole myriad of reflections from other places in the room that have radiated from the loudspeaker at strange angles, reflected off a bookshelf, reflected off a wall. On the picture on the right, you can see it reflects off the floor and the ceiling. And this results in a whole mixture of radiated sound waves hitting the listener's ears. And so this can have an effect on the sound and can give it what's known as some coloration, because when sound interacts, it's a bit like dropping pebbles in a pond. The sound waves, as they meet, they cancel and they reinforce each other at different frequencies. And this results in an altered frequency spectrum. If you recall from the first episode when we talked about the frequency spectrum, this could actually result in a different equalizer, effectively. Your room will be, to an extent, equalizing your sound. Now, equalizing is not quite the right word, because it suggests that you're trying to equalize something to be equal or flat, whereas in reality you have much less control over the actual impact of the sound from your room. Now, moving on to the next slide, this leads us very quickly onto room modes, because what happens in a room is at certain frequencies, it actually takes a very long time for these reflections to die away. And so it might be okay if it's moving at an odd angle and the sound might reflect off one wall at a strange angle and go off in all different directions. And if it does that, then it won't really reinforce itself. It will just decay according to various losses. For instance, if you have a very reflective room, with lots of hard surfaces, then it'll take a while to die away and you'll get this quite lively sound, and if you clap your hands you'll be able to hear it kind of decay over a period of time. But sometimes it's a little bit worse than that, because the nature of the reflection could actually reinforce the sound itself. It will still die off over time, but it will take longer and it will have more of an impact on the sound you hear.